Hello class. Today we will learn the principle of conservation of momentum and how it is applied to collisions of objects and explosions. Let's remember a few things we did last session. We defined impulse that we represent by uppercase J as the product of force multiplied by time. We define as well momentum that is defined as the product of mass and the velocity of the object. Impulse momentum theorems tell us that when you apply an impulse, it results in a change in momentum on the object. So J is equal to the difference of the final and the initial momentum. What is then conservation of momentum? Let's understand what conservation of momentum means by deriving it from a principle that you already know, the impulse momentum theorem. So let's write the impulse momentum theorem formula and let's break J as the force multiplied by time. What happens then when the net force applied to the object is zero? When the net force is zero, the term on the left side of the equation becomes zero. So we get that the change in momentum will be zero. We can rewrite this equality as final momentum equals the initial momentum. In other words, momentum is conserved when the net force applied on an object is zero. In other words, if the final and the initial momentums are constant, if they have the same value, that means that the momentum of the system remains constant. This principle applies not only to single objects, it applies when we consider a system that might consist of one, two, or more objects. Remember that last session we defined as the total momentum of a system that consists of two or more objects as the sum of the momentum of the individual objects. So momentum in a system of two or more particles will be conserved when the sum of the external forces acting on the objects of the system is zero. When there is no net external force acting on the objects of the system, we say that the system is an isolated system. Internal forces acting between the objects that are part in the system will not modify the momentum of the system. So, particle 1 might exert forces on particle 2 or particle 3. However, those forces between objects that are inside the system will not modify the total momentum. Conservation of momentum is a principle that can be very useful in a number of circumstances. Two of the more important and frequently found in nature are collisions of objects and when an object or system splits in multiple parts that move away from each other. This second will be called an explosion. It doesn't matter if the force that splits the object is really an explosion. It might be simply a spring pushing on the different parts of the objects. It doesn't matter if the force that produces the motion of the different parts of the object is really due to an explosion or due to the action of other forces. We will call it an explosion. So let's start by analyzing how conservation of momentum can be applied to explosions. An explosion is characterized by a very intense mutual force between the parts of the system that takes place on a very short period of time.